Hey guys, and welcome to the 6th video in our Pygame RPG series here on the Coder's Legacy channel. In this video, we're going to be implementing a very key feature, which is the enemy. We're going to set up collision detection between the enemy and the player, and it's going to be a bit tricky because we need to figure out that if the two are colliding, is the enemy attacking the player or is the player attacking the enemy? So there are a few things like this and some other cool features that if we have time, we'll take a look at. Okay, so let's not waste too much time and let's begin. This is our enemy image, okay, enemy.png. Now, the way we're going to set it up is that you can basically insert any image into it and the enemy will adjust accordingly, okay, because we're going to be using the getRect function, okay, so the size and everything will adjust. So you can just put anything in here. I just made up this little image in Paint, okay, for the purpose of this tutorial, and maybe we'll take a look at some cooler enemies later. Okay, so let's just open up the enemy file over here and begin coding. Okay, so first I'm gonna import Pygame. Okay, next I'm gonna create a vector object that will undoubtedly need later. Okay, vector2. Okay, let's make the class now. Class enemy and inherit from pygame.sprite.sprite. Okay, create the init function. Okay, and I'll take self as a parameter and call the init function of the parent class. Okay, this is all compulsory code, just you need to write it in. Okay, now let's begin creating the variables. First is self.image, which will load up right now. Okay, enemy is from the images folder, so images/enemy.png. Okay, now self.rect. Okay, we'll use the getRect function. Some other important variables are self.pos, okay, for the position. And what else? Self.vel for the velocity, which will give him undoubtedly. And what else is there? Well, there's going to be acceleration. This is the first time I'm giving an enemy acceleration. So I hope it works out well because I want to actually implement the concept of gravity into the enemy as well. Okay, I want gravity to affect the enemies as well, which is why I'm adding in acceleration. Okay, what else is there? Well, self.direction as well, actually. And for this, I'm going to import the random library. Okay, the random library is basically a very handy tool, very handy library that has a bunch of functions for generating random numbers and random ranges and stuff. Okay, check it out. I'll include a link in the description below. Okay, it's a very handy library. So I'm going to use this to basically generate a random integer from the ranges, and there's even a helpful prompt coming up right now telling us what's the range and how it works. Okay, so basically what I've done here is I've told it to generate a random number from between 0 and 1. So it's basically gonna either give me 0 or 1. And I'm gonna include in the comments over here that 0 means right and 1 means left. Okay, so basically if this generates 0, then he's going to move in the left direction, sorry, in the right direction. If it just generates 1, he'll move in the left direction. Okay, because we're not going to be controlling him, right? So we need to give him a direction, we need to give him some speed. So this is basically what we're doing here. We're giving him a randomized direction. Okay, so when he spawns, he'll either move to the left or the right. By the way, we haven't actually added in some kind of player following technique so far, so he won't be following the player. We'll actually be adding that into the next enemy that I have planned. Okay, so yeah, that's enough for now. Let's assign the velocity as well. Let's go up here and say random.uniform. Okay, and it was, yeah, this takes float values. So the speeds that I want are from 0. No, not 0. That's too low. From 2 to 4. Actually, no. 1.5 to 3.0. And I also want to sort of round this as well. Okay, because otherwise I could get some values like 1.54321 something. Okay, so I kind of want to round this off to 2 decimal places. Okay, so I know this is a bit complicated. This is the entire line, we have the round function, into which we put the random.uniform function, which generates a random integer between this range. Okay, so yeah, we have given it some random velocity now as well. We gave it some random direction. Okay, now let's figure out where to position this guy. Okay, well, I had this idea to make them drop out of the sky, but for that we'll need to implement gravity first, right? Initially, in the first game in this first version that I actually had planned out, I actually made them spawn in from the sides. But I think with gravity, I think it'll be kind of nice if to kind of drop out from the sky. Let's see how it goes. Okay, so let's make this move function, and over here I'll say self dot acceleration is equal to 0.5 and 0. Actually, sorry, wrong one. It's supposed to be the y that has the velocity, right? So yeah, I've given it the gravity force now, but we still need to add in a lot of things, honestly. We need to add in collision, okay, with the ground. And this is the group that it'll be colliding with, which is the ground group, basically. And what else do we need to add? We need to add in a render function. I'm just writing all these over here so we know what we have to do, okay? And let's just start with the simple ones first, honestly. For render, all we have to do is display dot, blit, okay? And what do you want to draw? Self.image, right? And we draw it to self.path. Okay, great. That's the starting point. And what else? Okay, these two are going to be a bit tricky. For the collision, I suggest we just copy over the player's one and then make some minor adjustments. So let's do that. Okay. Where's the player's collision function? Okay, here we are. And okay. So how much of this can we keep? Well, ironically, I think we can keep almost all of it. Let's just remove that over there. We don't need that. Looks good, honestly. I think so. This will work actually. Yeah, that's it. Okay. Now the move function. Okay. How are we gonna do this? Well, something like self.pause. Wait, no. We need to do this depending on the direction, right? If self.direction is equal to 0, then do this. If self.direction is equal to 1, then do this. If self.direction is equal to 0, that means he's moving in the right direction. So that means we want to be incrementing his. We want to be basically incrementing his. How do I put this? His position. Sorry. Yeah. So self.well, okay, and dot x, because we want to be incrementing the x direction. And we'll copy this over here and put this over here, but we just need to make this decrement, okay, to move him in the left direction. Okay, we've done almost all of it. There's just one thing we need to add, which I'm not entirely sure. Self.acceleration. How do we add acceleration into this? Ideally, we should just model it based off the player, I guess. Or maybe should we give our enemy friction, maybe? This is a bit of a tough question. So let's just go ahead and take a look at our player again, okay? Our player's move function. Okay. So we could just copy this over here. Okay, and put it into the enemy. And what else? We need to give him some friction. So self dot, what do we call it here? Self dot fric, right? Okay, and we'll just put a 0 for now. Okay, what else do we have here? Okay, good. There's one more thing we need to add actually, which is pretty important for the enemy itself, is that if self dot pause dot x is greater than if it's greater than the width, then I want you to turn around. Self dot direction equal to, if it's greater than width. Basically, this is something that's going to prevent him from going off screen. So basically, imagine that he's going right. Okay, he's moving in the right direction. But how far is he gonna go? He's gonna go reach the end of the screen, right? Which is basically of x value width, right? Because that's the furthest point in the screen, which is the width. So if he goes further than that, what I'm telling it to do is basically reverse his direction to go left. Okay, I'm gonna copy this concept over here. Self.pause.x is less than 0. Then I want you to reverse your direction to move in the right. Okay. Okay. Woof. This was quite a bit. We wrote all this code and we haven't even tested it out, honestly. So I'm a bit scared. Okay, so I think it looks good. I think we should give it a shot now. Let's go into our game file over here, okay? And the first thing we're going to do is actually import the enemy from enemy, import enemy. And what am I doing here? Full screen. Okay, so let's go down here and create a new group called enemy group. Okay, this isn't that important right now while we just have one enemy, but it will be important later on. Okay, so let's make our enemy. Let's call him E1. E1 is equal to enemy. Okay, and we didn't make any parameters, right? So it's just going to be fairly simple. Okay, so what else do we have to do? We just go down here and say E1.move. Okay, E1.collision. We'll make an update function for this later on, and E1. We need to render it as well, but we need to render it after the background over here. So I'll do E1.render display. And collision takes a ground group as well, right? Just like the player. So let's see how this goes. Okay, an error right off the bat. What is this? Okay, let's see what's going on here. Let's go to our enemy. And why are we having an error over here? I think it's because of this. Okay. Run. Width is not defined. Fair point. We defined width over here. We never actually defined it in the enemy. That's a bit annoying. And for now, let's just put this to 800 manually, okay? And let's just go back here and run it to see if our code is actually working. Okay, that's what we want to see right now. And no, not really. He just fell off the screen. Let's just try running that once more. Not very good. Not a very good effect. If I think about it, I never actually added the rect. I never changed the rect in the enemy function, the enemy move function. You know, just like in our player over here, we did this, right? We never actually did this for our enemy because we need to move the rect. Otherwise, it'll never detect collision with the ground. The rect was probably still sitting somewhere up there. And while we're at it, let's also randomly generate his position, okay? Because he was just starting from the top, was it the top left corner? Yeah, he was starting from the top left corner, okay? I don't want him to do that. I want him to start from some random place from 0 to 800, okay? That's a lot better. So he can randomly pop out from the sky anywhere, okay? So let's see what happens. And I don't know why this is lagging, but okay, why isn't he moving now? That's a bit concerning, but at the very least, he's there. Okay, so let's see why he isn't moving. Okay, go over to the enemy over here. And the reason why he isn't moving. Well, I guess the first thing we should do is honestly change the acceleration, the way the acceleration is being handled to how it was being done in the player. Because what is his acceleration? He doesn't have any, does he? So let's go here and say self.acceleration as a constant. And this is where I realized that I actually should have done it like this. That the velocity should have been initialized to 0, and this should have been over here with the acceleration. And let's just tone this down a bit. I'm not sure what's going to happen exactly, honestly. So at any rate, okay, and I'm going to make this self.acceleration, and this will be self.acceleration over there, okay? And minus, okay? Because this needs to be negative acceleration, this needs to be positive acceleration, okay? Positive in the right direction, negative for the left direction. And now we're pretty close to how our player's function was made, okay? And I hope this is gonna work. And you know what, let's just make the friction some really low value, okay? Just so that maybe that was causing problems, okay? So let's just try this out. Well, he flew off somewhere. Okay, so what is the problem? He's going way too fast. Let's give him some low value from 0.1 to 0. Okay, I'm just testing things out here, and it just takes a lot of testing to actually get these things done. Okay, he's coming around, but he's not warping. He's not warping like I told him to. Why is he not doing that? Okay, his direction isn't turning. Why? Or maybe because I didn't do it correctly in the first place. If it's greater than 800, he should go in the left direction, right? And if it's less than 100, he should go into the other direction. Why isn't he doing that? I think the problem lies in the values that we've kept here for friction, acceleration, etc. For one, actually, friction should be a negative value, not positive. Friction is a negative force, okay? And let's keep this minus 0.1, okay? It's just like the player. We also need to speed him up a bit, I think, okay? So we'll do this 0.1 and do this 0.2. I initially had this at 1 and 3, I believe, or something, and that was too fast, but 0.01 is a little too slow, okay? So one more thing. I think we should decrease these a bit, okay? At least I mean to decrease this one, okay? So let's go here, okay? Because I don't want him to basically go off the screen and then come back, okay? I want him to turn back a little before that. So let's run this. I still don't know why it's lagging, honestly, but it's because of the screen recorder, I guess. And you know what? In the next video, I think I'll actually take a look at performance and stuff. Because while this is an external issue causing these slowdowns, there's still a way we can easily speed up our game and make it much faster and much smoother, okay? So we'll actually take a look at that in the next video, okay? But this looks like it's working correctly. The enemy is spawning correctly, he's moving correctly, okay? And yeah, pretty good. So yeah, I think we're done here with the main part for the enemy, that is. Now we need to set up collision detection between the enemy and the player. So let's implement collision detection, okay? Trust me, it's not that hard. So I'm going to go down here and say def player collision, okay? And over here I'll take the player, okay? And then over here I'll say if self.rect collide rect player.rect, okay? So this will return a Boolean value, true if it is colliding and false if it's not. So if it is colliding, what I want you to do is self.kill. Hold on, there's one more thing I need to do actually. We don't want to kill it as soon as it collides with the player, because what if it's attacking the player? So I'll do this. If player.attacking is equal to true, then kill it. Otherwise, player was hit. Print this out. Okay, and you know what? Let's just remove this kill function. Kill is an inbuilt function basically that kills a sprite. Okay, let's just remove this for now. Okay, because I don't want to kill the enemy right now. Okay, we'll do that later. So over here I want to say enemy was hit. Okay, let's just work with simple prompts for now. Okay, so I think this might just be it. Okay, I don't think we have to do anything else. Let's go over here and call this function e1.player collision, and it takes player. Okay, let's run this and hope it works. Okay, we made a slight mistake here. Slight miscalculation, actually, more like. And I'm seriously gonna get this performance fixed in the next video, okay? Because it's getting a little too much now. Basically, I forgot about the fact that we actually have two rects now, okay? So what I want to do here actually is that if it collided with the player rect, okay? Because in the previous version that I made, I didn't actually have two rects. I just had one generic rect. And the current system I was using was designed for that. But we have a better system now. So I'm going to say that if you collide with the player's rect, which is also the player's hitbox, print player was hit. Otherwise, if you elif self.rect.collide rect with the player's attack range, okay? So basically, if you're colliding with the player's attack area, okay, print enemy was hit, okay? This is a more neater system. And now let's go here and hope it doesn't lag too much on us. Okay, hold on about that. Okay, it's stubbornly insisting that I'm the one who's being hit. It doesn't seem to be registering. Okay, it does. Clearly something is wrong here and we need to find out what it is, okay? So I'm going to go to the enemy render function and I'm going to say pygame dot, what was it? Draw rect, right? Let's just go back down here and remember this. I'm going to use this basically. This, I'm going to basically draw out the rect onto the screen and then find out what's going on, okay? Self.rect, okay? We're going to draw the enemy rect on screen. So I'm going to go and run this now. Okay, look at that. I think I know what the problem is here. I think I know what's going on. Okay, first of all, let's just go and change the color. Okay, because it matches the attack range right now, which I don't want that to happen. And second of all, there we are. I accidentally copied this line over when I was doing it from the player, okay, and which we did. We only did this for the player because we needed to center it. We need to center his hitbox. We don't need to do that for enemies. And that was the problem. Okay, good. That is the enemy now. And see, it is now accurately registering hits. See, you can't see that, but if you look at the scroll bar right now, you can notice that it's going smaller because it's being hit. Accurate, good. Okay, I know the performance was horrible, and that's because of the screen recorder over here. But don't worry, I think this has gotten a little too much, and in the next video, we're actually going to take a look at how to fix performance, okay? Well, and actually in the next video, we'll take a look at a lot of small things. Let's take a look at player warping. Let's take a look at adding in new ground elements, by which I mean let's add platforms, okay? Let's add platforms and onto which we can jump to and stuff. And we'll take a look at a lot of cool things in the next video, of course. So make sure to subscribe, make sure to leave a comment, make sure to leave some suggestions, make sure to leave a like, okay? Again, we have a lot of interesting stuff coming up, okay? Like in the next video, I told you we'll have a lot of small improvements, and after that we can begin adding in stuff like more world elements maybe, or maybe we can go ahead and add in the health and stuff. There are a lot of things to be adding, okay? You can also take a look at the website if you want to get an idea of what's coming up next, because the website it is a slightly old version, but a lot of the stuff in there is basically what's going to be in our series right now, okay? Like new enemies, magic spells and stuff. Those are all upcoming, okay? So yeah, make sure to subscribe and leave a comment, and I'll see you guys in a later video, okay?